Alright, so problem 2 from section 9 says the dot plots below show the number of miles run by members of 2 track teams during one day. So our first dot plot is talking about team A, our second is talking about team B. It says which statements below are true, select all that apply. So this is another one where we want to go through and check every single option before we select our final answer. So the first one said the mean of team A is higher than the median of team A. So remember in the last question, we learned that mean is the average. So if we were to add up all the numbers and divide by the number of numbers there are, and then the median is the middle number. So we talked about symmetric or not symmetric distributions when we learned about this section. And if we look at the distribution here, I draw my curve, it's a normal distribution. It's symmetric. And when we have a normal distribution, our mean and our median are the exact same thing. No one is going to be higher than the other. So we know that this one is going to be false. The second one says the distribution for team A shows a symmetric distribution. Well, when looking at the first part, we said it was a symmetric distribution, so we can go ahead and say that this one is true. Symmetric meaning that we have the same, if we split it down the middle, we have the same number of dots on either side, and our curve is not shifted one way or the other way. Like we see in this one, if we were to draw our curve, it's very skewed one direction. So this would not, team B would not have a symmetric distribution. If we look at the third one, the data for team B shows that most team members ran a greater distance than the mean. So with the mean being the average and the median being the middle, we see that most of our data points are clumped on this side, right? Most people ran a higher number, a longer distance. And so when our graph is shifted this way, we know that our median is going to be higher than our mean because most of our data points are shifted over here on the right-hand side. So that one's going to be true. Now it says the range of data for team A is greater than the range for team B. So range is when we have the biggest number and we subtract the smallest number. So if we do that for the very first one, the biggest data value we see for team A is 0.5, and I'm going to subtract the smallest data value, which is 3. 5.5 minus 3 gives me 2.5 for my range for team A. Let's look at it for team B. The biggest number I see for team B is 6, and the smallest number I see is 3. So 6 minus 3 gives me 3. The range for team A is actually smaller than the range for team B, so we're not going to select this answer choice. Now it says 75% of team A members ran at least 3.3 miles. To figure out how much 75% of team A members ran, we first need to find out how many people were on team A. So let's go ahead and count our dots. So when I count, I get that we have 18 dots. And I need to know what 75% of 18 is. So I'm going to do 18 times 0.75. Let's see what I get. 18 times 0.75. That gives me 13.5. So, since it says at least 3.5 miles, that means I want to know how many people ran an amount greater than 3.5. So when it's looking for the amount greater, I'm going to start counting my dots at the biggest dot, and I'm going to count to where I find between 13 and 14 to see where that number is. So I'm going to count until I get to 14. Okay, so this dot is number 13, and number 14 would be on 3.5. So it is true that 75% of Team A members ran at least 3.5 miles. So I was looking between these two dots. The very last answer choice says 75% of Team B members ran 5.5 miles or less. So again, before I can do anything else, I need to find out how many people are on Team B. So I'm going to count the dots. get 23 dots for this one.